afternoon. How's everyone doing? Good. Alright, how are we liking object-oriented movies so far? The best. Okay, the best. And then I hear some groans underneath. Alright, so I want to let you guys know that we'll have plenty of opportunities to practice object-oriented Ruby. We'll be able to kind of calm your nerves. Again, what I like to do in lectures is kind of sit back and relax and just kind of absorb what you can. If anything, lecture is the fun time. It's almost like watching a movie, and then you have to go back to do your board games. Okay? All right, so let's get this movie started. Yesterday, we talked about having different types of classes and knowing that these classes are related to each other in some way. So an owner has many dogs, or a user has many tweets. So let's take an example where we are running a healthcare system where a doctor has many patients. So Dr. Hart, he is a cardiologist. He has some patients. His patients include Hermione and Ron. And then there's Dr. Eyes. She's an optometrist, where her patients are Harry and Draco. So what we've got here is a one-to-many relationship. One doctor has many patients. A patient belongs to a doctor. This is just review, right? So let's say we translate that into code, and we haven't talked about databases yet, but for the time being, just think of databases as fancy spreadsheets. Many of you guys have seen a Google spreadsheet or an Excel spreadsheet. A database is just a fancy spreadsheet. So if we have this concept of one doctor has many patients, what does that look like in code? Well, a doctor is initialized with a name and a specialty, so like cardiology or optometry. What about a patient? A patient is initialized with a name and an age and with a doctor. Because the patient is the one in the, the patient is the many in the one-to-many relationship. We make it the job of the patient to be like, hey, you're going to keep track of your doctor. Well, let's see what that looks like in a database. So a doctor is initialized or has a name and a specialty. What that means is we'll probably have a doctor table or a spreadsheet that says, hey, every doctor row is going to have a name and specialty. What about patient? What is patient going to look like? Well, a patient is initialized with a name, an age, and a doctor. So that means a patient is going to have a name, which is a string of Hermione, Ron. A patient's going to have an age. All of our wizards are going to be 11 years old. And then a patient is going to have a doctor that is not the doctor string, but the doctor object itself. Now, we saw how this is possible. So even though age is a string, name is a string, age is going to be like a number, the doctor property of a patient is going to be a doctor instance, so something we store in a variable or something of sorts. Now, let's say in our healthcare system, we decide to open it up a bit. Ron is having some problems with his eyes. So even though he has his doctor who's a cardiologist, he goes to his good friend Harry, and Harry recommends his optometrist. And Ron goes, sweet, she sounds like a great doctor. At the same time, Harry is only 11 years old, but is having some heart problems. He will ask his good friend Ron, do you have any cardiologists you would recommend? And Ron says, yes, you should see my doctor. Dr. Hart, great with people. So what we have now is, yes, Dr. Hart has many patients, so Hermione, Ron, and now Harry is a brand new patient. But what we also see is on the patient side, Harry now belongs to two different doctors. So really, in a sense, Harry doesn't belong to any one doctor. Now, it's almost as if Harry has many doctors. And this is how real healthcare works. So Harry has a doctor for cardiology, and Harry has a doctor for eyes. Other patients might only have one doctor, but a patient can have many doctors. And at the same time, a doctor can have many patients. So what is this? Ooh, what was that noise? What is this going to look like in code? Well, let's try this. Before, if we had a patient belongs to a doctor, we say, okay, you know what? It's the job of the patient to keep track of its doctor in an instance variable. But if a patient now has many doctors, well, we could try this approach where a patient now has an instance variable of doctors, which is an array. But here's the bigger problem. Eventually, once we get to databases, we can't store an array in our database. So again, a database is a fancy spreadsheet, And in an Excel spreadsheet or a Google spreadsheet, you can only really have one piece of data in one cell. Likewise, if Hermione has many doctors, well, in this case, she has one doctor, Dr. Hart. But if Ron has many doctors, he sees Dr. Hart and he sees Dr. Eyes. This is a problem because we cannot store an array in a database. So, what the heck can we do if we can't follow this approach? The solution is going to be to add another table, or in Ruby world, we're going to add another class. Something that is going to represent the relationship between a doctor and a patient. So, how this translates to database world is now we don't have to store arrays at all. We have the concept of a doctor. A doctor still has a name and a specialty. So Dr. Hart specializes in cardiology. We still have our patient class. Our patient class is still going to have their name, Hermione, and the age of 11. But now we're going to have a separate class that is literally going to represent the relationship between a doctor and a patient. So object-oriented programming is used to model more than just real-world objects. They're also used to model abstract things, like a relationship between a doctor and a patient. Well, let's take a look at how a doctor is related to a patient. So if I look at my new class, let's say in theory, we create a class called Doctor Patient. What does that class represent? It's going to represent an instance of this doctor is associated with this patient. So what does that look like? Well, Dr. Hart is associated with Hermione. Well, what does that mean? It means Dr. Hart has as his patient Hermione, and Hermione has as her doctor, Dr. Hart. Dr. Hart is also associated with Ron. Dr. Eyes is associated with Harry. Dr. Eyes is associated with Draco. Dr. Hart is associated with Harry, and Dr. Eyes is associated with Ron. So what this means is Harry can have two different doctors. That's fine. We see Harry here twice. One of these doctor-patient instances represents Harry's relationship with Dr. Eyes. And a separate instance is going to represent Harry's relationship with Dr. Hart. So if we add, this is what's known as a join table. Literally this table or this class, the only purpose it serves is to join a doctor and a patient. So I'm just throwing out more terminology at you guys. A join table is going to say, my two main models are doctor and patient. I'm going to create a way to join them together so that no one doctor owns a patient, and at the same time, no patient owns the doctor. There's going to be a many-to-many relationship. Many patients have many doctors. A doctor has many patients. This is also known as a has-many-through relationship because in order to see which doctors are associated with which patients, we have to go through the join table. This is all just terminology. But I want to ask you guys, conceptually, what questions do you have? What's it, Michael?
So, in Ruby, is there a name for the join table, or just call it join table?
So in our case, this is a join table. We can call it whatever we want. Maybe we don't have a good name for it. Like, what do you call a class that is used to represent an abstract concept? Like, I'm related to my mom or my dad. Like, what do you call that? You can call it whatever you want. In this example, we've just decided to call it a doctor-patient. So what is a doctor-patient? It means this doctor will see this patient, and this patient goes to this doctor.
And is there also any sort of notation you use to connect the tables?
We'll get to that in just a second. Dawa, you had a question.
I was going to say, for each doctor and doctor-patient, other on instances, right?
Yeah, so just like we have we have 2 instances of doctors, and we have 4 instances of patients, we're going to have 6 instances of this doctor-patient relationship. And that makes sense. If you see, we have 2 red doctors, 4 blue patients, but we have 6 of these lines. Each one is going to represent a doctor-patient relationship. In this case, they are technically not named the same, so doctor is different than doctor-patient. And patient is different than doctor-patient. Again, this middle abstract class, we don't have a good name for it, so sometimes we just name it what it connects. doctor patient. You know, mom, daughter, dad, son. I don't know, what do you want to call that? Okay, so, Michael, to answer your question, this is what it's going to kind of look like when we draw it out. So remember before, we would model our program, we would model our domain by saying, you know, a doctor has many patients. Well, this is how it's going to change. A doctor is going to have a name and a specialty. That makes sense. A patient is going to have a name and an age. But a doctor-patient, remember what that represents. It represents the relationship between a doctor and a patient. So what data does a doctor-patient need to remember? Well, it needs to know its doctor, and it needs to know its patient. So if that's the case, if this middle model says, hey, it's your job to remember the doctor, well, that means a doctor has many doctor patients. And then at the same time, this middle model, this drawing table, a doctor patient is responsible for keeping track of, hey, here's a doctor, here's a patient, that's a relationship. If this doctor patient keeps track of a patient, well, that means a patient has many doctor patients. A doctor patient belongs to a patient, and a doctor patient belongs to a doctor. And you can visualize it in this way. If I say this green line right here, what doctor does it belong to? You just follow it. It belongs to Dr. Hart. This green line right here, what patient does it belong to? What belongs to Harry? So this relationship belongs to a patient, and it belongs to a doctor. How we draw that out? We got little chicken feet going towards the middle. What other questions do you guys have so far? Now let's talk about what that looks like in code. So one of the great things about domain modeling is you are forced to write out your properties as well, or your instance variables. So again, doctor has a name and a specialty, where name is a string, like Dr. Hart. Specialty, also a string, like cardiology. Patient has a name and an age. This is a string and a number, respectively. So the string is Harry Potter. The age is Harry's 11 years old. But this is the interesting part. This new class, literally used to model a relationship, is going to be initialized with a doctor, where doctor is not a string. It's going to be an instance of the doctor class. Same thing with patient. Patient isn't going to be a string. It's going to be an instance of the patient class. What's up, Asa?
Kind of doctor patient, not like in general, kind of doctor patient, the middle, the joint table. Can it have like 3 variables, or should it always be only two?
So the middle table can have 3 variables, so it can join, you know, a doctor and a patient and a hospital. It could. If you can master a join table between 2 classes, the 3rd class is just another extension. So it'll be an easy tack on, but what we're going to focus on in this class is the fundamentals. We have 2 main models. Let's try to relate the 2. Remember, the purpose of the join table is to say, hey, a doctor can have many patients, and a patient can have many doctors. That's the reason why we have this join table. Okay, let us now, whoops, spoiler alert, translate that into code. So the challenge of the many-to-many relationship is that one model does not belong to another. Doctor doesn't belong to a patient doesn't belong to a doctor, because there's like so many. It's like a big old shared networking. So we don't want to make it the patient's job to keep track of all their doctors. We're going to put that responsibility onto our new class. We're creating a class specifically to keep track of all the doctor-patient relationships. And the solution is going to be to create said class. We're going to call it, in theory, we would call it doctor-patient. So the example I gave you, let's build out something else just to give ourselves more practice. To stick with the social networking theme, yesterday we built out Twitter. Today we're going to build out Pinterest. Now Pinterest is, for those of you who don't know, it is, let me see if I can show you. It is like this website. The concept of Pinterest is that you can sign up as a user and you can kind of curate your own pins So let me just read the description first. So Pinterest is a way where a user has the ability to like just kind of curate pins. There are thousands of pins and thousands of users. A user can save many pins, and the same pin can be saved by many users. So with Pinterest, you can search all sorts of things. You can search like, recipes. You can search, desserts. But the purpose is there's thousands and thousands of these things called pins. For the most part, they're a picture and maybe a link to an article, like how to create this recipe or like how to build this bookshelf. But the minimum version of Pinterest is, as a user, I can hover over all these and then I can click save. And what that does is it takes this pin and it saves it to like my personal board. So I can collect all these pins. Someone else on the internet can collect all of their pins, and we might have some overlapping pins. So if Paul and I were both on Pinterest, we might pin lots of different things. So I'm a big dog person. I love all the cute little puppies. I can actually show you guys. This is going to be so cute. I can look for puppies. And I can see, look at all these cute. This is adorable. Oh my God. This was a mistake. I'm going to want to be on here forever. Anyway, so I can save all of these. And Paul's not going to want to save these pins. He's a cat person. But maybe there's some stuff that we do want to save in common. So like we both like to code. Maybe I think, this is like Morse code. Interesting. Oh, coding project. So I think this is really cool. I will save this to like my personal collection, and Paul can save this exact pin too. So if we think about what is the minimum version of Twitter, a user has the ability to save pins. A user can save many pins, and the same pin can be saved by many users. So this is known as a many-to-many relationship. I'm gonna draw it up here. What's a good place where everyone can see? Interestingly enough, I think more people can see this board than that one. So this is what our models are going to, our domain model is going to look like. A user, I'm going to draw it like this. A user and pins are two separate classes. Now a user is going to have many pins, and a pin is going to have many users. Now this isn't a good relationship diagram because we're missing our join table. So I'm going to redraw this, and I'm going to create, oh, there's a question. Oh, no, sorry. So I'm going to create a third model. And I could call this model like a user pin. I'm going to call it something else. I'm going to call it a save. So a user can have many saves. So what that means is, as a user, I see a pin. If I click on the save button, that is my save. But at the same time, a pin can be saved. So what does this look like? A save is literally going to represent an abstract concept of a user saving a pin. So that means a save is going to have to keep track of its user, and it's going to have to keep track of its pin. Let's think about other stuff we might want. Let's say we want our users to have a username, and our user should have an age. And let's say, like, what does a pin have? So a pin has a picture. If I click on it, it has a title, and it has, whoops, didn't mean to click that. It has a title, and it has a description and more stuff. Let's start simple. Remember, we want to build the minimum version of Pinterest. Let's say a pin has a title and has a description. So this is what our domain modeling is going to look like. A user has many saves, so I've saved many pins. A save belongs to a user. A save also belongs to a pin, and a pin has many saves, so a pin has been saved many times. What questions do you guys have about our domain? What's up, Michael?
So save is where like the many relationships is for many to many.
Exactly. Well, so a save is going to represent a relationship between a user and a pin. So if a user likes, or if a user says, hey, I really like this pin, I want to save it, the save is going to be that abstract relationship now. Okay. Let us now practice building out what this would look like in code. So let's review some easy stuff. I'm going to show you guys this file I have. So yesterday I had a run.rb. I have something very similar. I've named it differently. I've named it a little bit closer to what you'll see in your labs and your challenge later next week. I have a file called console.rb. And console.rb is under this folder called tools. So I'll show you guys what that looks like. So I'm in my folder. If I do ls to see all my folders, I have this readme, which is my notes. And I have this folder called app and a folder called tools. Inside tools, so if I'm going to change into tools, I only have one file called console.rb. I'm going to go back up one. So now I'm in my original folder. If I change into app, app is going to be where I have all my classes. So this is just a better way to organize your code as you get more and more files. All my classes I'm going to put in a folder called app because they make up my application. And then the console.rb is a tool I'm going to use to run my code. So let us go back to the root directory. So just to show you guys right now, I'm inside my root folder where I have app and tools. And I'm going to say Ruby in order to run. And then I'm going to say, instead of a file name, I'm going to give a relative path to a file. So I'm going to say run tools / console.rb. So this is going to let me run the console file inside the tools folder because where I'm currently at, I don't have that file. I have to first go into tools. And I've hit my binding.pry. So my binding.pry. Here's the world so far. I can create users, so user.new, and I can create pins, pin.new. I'm going to take this time to go over our starter code. It should be reviewed. So the world so far is we can create a user class, and the user class is going to have these methods. So I can initialize a user. If that's true, I can say something like Chine is equal to user.new. Ooh, wrong number of arguments given 0, expected 2. Well, let's go to user. And we can see that the initialize needs to take in 2 variables, the username and the age. So that was my mistake. I should add in Chine. I'm going to do Chine with a lowercase c, by the way. Let's try that. So Chine is equal to user.new, and then I have to add in an age. We'll say 30. So my user initialize method works. That was already done for us. User.username. So given Chine, can I get her username? Yes. So Chine was initialized with the username capital CHINE. The reason username works is because I wrote it as an attribute accessor. So this means I can actually read and write to the username. So does Chine have a method called username? Yes. Yes, she does because of this attribute accessor. So this is all done. Ooh, given a user, can I invoke an instance method of age? Let's try Chine.age. Yes, this works just as well because, again, I wrote it as an attribute accessor. So I can read the age. I can also write the age. Let's say she's 32. So what is Chine.age now? Oops, I misspelled Chine. Chine.age is 32. So can I read the username? Yes. Can I write the username? So these 2 methods, user.username and user.age, we created those through the attribute accessors. User.all is a class method. That's what this dot is. So we can only call class methods off of a class. Chine.all, that's not going to work because I have a class method. I'm trying to call it off of an instance. So let's do user.all. That's going to give me all my users. Let's see why this works. Because I have this class method, self.all. It's going to return me this class variable. I've created a class variable to keep track of all my users, and I push in the user every time it's initialized. So this is our review. All of these methods are built out. Given a pin, can I initialize a pin? Well, let's see. The code pin, I was able to initialize it on line 11. So what do I need to initialize a pin? Well, I need a title and description, both of which are strings. So, okay. So this pin has a title of coding tips. It has a description of hello world. So I can initialize a pin. Pin.title, so let's say code pin.title. That works. Code pin.description, that also works. You guys might have guessed it, yes, because I've created attribute accessor. So this is going to create the title method for me and the description method for me. I can also do pin.all. That will give me all of the 3 pins that I've created every time I load up this console.rb. So that is our code so far. What questions do y'all have? Does all seem like review? Okay, I see some head nods. This is great. Okay, so that was a bit of a review. Let's now talk about the new stuff. Let's go ahead, go to the README. And these are the deliverables we're going to build first. So our save class, it's looking really empty. We haven't ever built out an abstract relationship class anymore. What we should do is we need a way to initialize a save. So a save should be initialized. And what does it need to take in? Well, according to our domain model diagram, it needs to take in a user and a pin. So let's stick with our domain diagram. Let's also stick with the instructions. It says, save.initialize needs to take in a user and a pin. Let's say define initialize. It takes in a user and a pin. And then a save is going to have an instance variable of user. It's going to have an instance variable of pin. Okay, let's see if this works. So if I clear this out, run it. Let's do this. So I have 2 users and 3 pins. Let's pick a user. Someone shout out a user. I'll choose the first one right here. Anne. Okay, let's go with Anne. And let's say Anne is going to save one of these pins. Which one of these pins do you think I should save? Dogs. I love dogs. I'm so glad you guys said that. So let's go ahead and say we've coded this. Let's go to save. Yeah. We've coded this initialize method. So code a little bit, test a little bit. What I expect is if I try to initialize a new save, save.new, I'm expecting no errors as long as I pass in the right stuff. Well, let's see what stuff I want to pass in. I want to pass in a user instance, like Anne. And the second thing I want to pass in is a pin instance of dogs pin. Press enter, and I misspelled dags pin. Let's try dogs pin. And no error. What I get back is a save instance. And that save instance has 2 instance variables, a pin and a user, where the pin is an instance of our pin class, and the user is an instance of our user class. Like, this is where things get kind of complicated, but not more complicated than what you guys are used to. You guys have seen an array nested inside a hash, nested inside another array. All this is a pin instance nested inside of a save instance. Okay. Now, our save method, we can initialize new saves. So let's do this. Instead of having to type it out every time, I'm going to create some new instances of save. So save1 is equal to save.new and dog pin dog. Let's go ahead and, we know this works, but let's just double check. If I run this, I can check what is save1, what is this variable. Okay, it's an instance of save, And inside of it, it has an instance of pin and an instance of user saved in its variables or its properties. Let's keep going. Let's say save2 is equal to save.new. Let's give Paul some love. Paul is going to want to save the cats pin. DATS. You guys know by now I'm very awful. Let's say save number 3 is equal to save.new. And I am interested in coding, so I'm going to save this code pin, and then save 4 is equal to save.new. I'm going to say Paul also likes to code, so he's going to save this coding pin. If I kill this, I'm going to restart my console.rb. It'll hit my binding.pry, and I can test what I just coded. So I created save 2, save 3, save 4. Let's just see that those are what I expect them to be. So I expect them to run with no errors when I say, show me save number 2. No errors. Okay, show me save number 3. No errors. Okay, show me save number 4. No errors. If I say, show me save number 5, now I get an error because I didn't create a variable called save5. I didn't create a 5th instance of a save. Okay, so we've coded a little bit. We've tested a little bit. Now, let's build out some more basic deliverables. So given a save, I should be able to find that save instance's user. So as an example, here is my save1. Save1 is a relationship between Anne saving the pin, good dogs. If I say save1.user, this errors out, but what should save1.user return? What's that supposed to be?
The instance of Anne.
The instance of Anne. And how we do that is actually much easier than you might think. So if I want my save instance to have a method called user, let's define a method called user. And it's just going to return the user instance saved in this instance variable, saved as its property. If I kill this, run my application, here's save number 1. Save number 1.user is our instance Anne. But what's an even better, what's up, Michael?
I was just going to answer the question.
Yeah, Michael, what's a better way to write this?
Attribute reader.
Attribute reader. So let's not even write this. Let's create an attribute reader for user. That looks right. Did I write that wrong, or is that okay?
No, it's good.
In the class, though.
Oh, you're right. No, you're absolutely right. I need to do it in the class. I was silly. Great call. Now let's run this again. So given a save, so here's our very first save between me and the dog pin. Save1.user, give me my Anne. That's awesome. Let's say I don't want to edit this. I don't want to make it an attribute accessor. Once you save a pin, you shouldn't change who that save belongs to. So we'll keep it attribute reader. Let's do this now. Given an instance of a save, so save #pin, that means create an instance method called pin that you call off of an instance of save. So, given an instance of a save, save1, I should be able to say .pin. And this gives me an error. Let's have a raise of a hand. What should save1.pin return? Raise of a hand. Any volunteers? Lindsay again.
Instance of pin.
Our instance of pin. And which instance of pin?
We did save 1 pin
Mhm.
with the, sorry, I can't see what one that was.
Yeah, so,
Oh, that's right there.
yeah,
Oh, the dog.
the dog one. So, I could also create a method called pin and have it return this instance variable, or I just put it here. Now I close my pry, spin it up again. So save1 represents the relationship between Anne and the dog pin. So save1.user is Anne, save1.pin is the pin that Anne first saved. So we are taking what we already know about object-oriented programming and just applying it to something new we're learning. It's just a different way to think of it. Okay, now, it'd be really nice to have a class method, save.all. Save.all. It'd be great if this method, this class method, could return an array of all saves in my entire Pinterest application. So we're going to do the same exact thing for any regular model. It's okay that this is a join-like model, it's a join class. How do you do it for a regular class? We can do it here. We can create a class variable called all, which is an empty array. So at first, there are no saves. Like a brand new version of Pinterest, you have some users, you have some pins. No one has saved anything yet. But every time a save is initialized, we're going to shovel it in. And then, how would we actually create a method called save.all? What would I have to write, Junior?
We can do def all, and we can do self all, and we can do
exactly.
Add all, and we can close the function.
Oh, we can close this function. Let's test this out. Let's code a little bit, test a little bit. Now, if I do save, that gives me my save class, save.all. I have an array of 4 different saves. It might take a little while to read through it and parse it, but here's the first save, here's the second save, here's the third save, here's the fourth save. And inside each save, we have embedded in it, one pin and one user per each save. Because that's what a save is. It's a pin and a user. Okay, now, this is where stuff starts getting real interesting. Oh boy, I'm going to stretch for this. I feel like I'm about to work out. Now, we are going to take some time to build out methods that are meaningful relationships. So user hashtag pins. This means we should write an instance method called pins that you can call off of a user. So given a user, so like Ann.pins should return a list of pins saved by Ann. Paul.pins should return a list of pins saved by Paul. So while I might not know how to do this yet, let's start writing the method. So Ann.pins. This should return an array of Ann's pins. This method doesn't exist, so we can go to user. We can define a method called pins. And let's just have it return, testing 1, 2, 3. Something silly. But it's silly things like that that remind you to code a little, test a little bit. So now, when I do Ann.pins, I get testing 1, 2, 3. Yeah, that's not what I'm trying to build, but I know that I wrote my method right. I know that I set it up to be called right. Okay. Now this is where things get tricky. How the heck do I find out find a list? So remember, a list is an array. How do I find a list of pins that Ann has liked? What's up, Junior?
So I have an idea. Maybe we just create an array with all the pins. Can we just use that?
Did we create an array of all the pins? Let's take a look at that. So I have my Ann. So this is my Ann, perfect. I also have my pin.all. And this gives me an array of all pins ever created. Okay, so we have we have 4 saves and 3 pins. So the saves are Ann likes cats, Ann likes coding, and then Paul likes cats and then coding. So 4 saves, 3 pins. Now this is cool. Don't get me wrong, this is a great stuff. Pin.all is going to show you all the pins so I can see. So fluffy, so floofy, cute cats, here's a treat just for you, good dogs, hello world, coding tips. Unfortunately though, pin.all doesn't give me any useful information about which of these pins does Ann like. But we're on to something. I want to show you guys a different way to visualize what we've got so far. This is what we have so far. We have 2 users. Ann is 30, Paul is 40. We have 4 pins. We have the cute cats pin, the good dogs pin, and the coding tips pin. And we have 4 relationships. Anne saved dog, Paul saved coding, Paul saved cat, and Anne saved coding. I want to ask you guys this. Given Anne, I'm going to highlight this in red. Given Anne, look at this data. What pins has Anne saved? Let's have a raise of a hand. What's up, Junior?
She saved dogs and code.
Dogs and coding. That's a good answer. But now I'm going to ask you, how did you know that? Like, explain to me like I'm 5 years old. I just see Anne 30. How do I know that Anne likes good dogs and coding tips?
Because we've seen it earlier on our user.
We saw, well,
On
where,
our saves, I mean.
we saw it earlier, but where do we see it now? Like, as a user, as a human being, reading this data, how do you know that Anne has saved good dog and coding tips?
Well, we got a relationship that's telling us that.
We got a relationship that told us that. Okay, so tell me, like, explain to me literally like I'm 5 years old. How did you know Anne likes good dogs and coding tips? How do you know Anne doesn't like cats?
Because Anne saved the dogs and codes.
Anne saved the dogs. What else does Anne save?
Code.
Anne saves code. So I want to bring you back to the problem we had earlier. I apologize for the squares that are now on the screen, but remember, if we try to go look at pins directly, we only see the title and the description, right? That's exactly what we see here. If we try to go to pins directly, like if I had tunnel vision, if I look at pins directly, I only see title and description. I don't see any information about Anne. That information is stored on our saves table. So, given a user, you can go through the join table and say, okay, find me all the saves that involve Anne. Notice I didn't circle Paul code or Paul cats. I said, here are all the saves. I only want to select the saves that involve Anne, because Anne is what I'm interested in. Now, from this join table, how do we know that I like good dogs and codings? Well, because Anne liked something called dogs. So where is dogs? Dog is right here. So this is good dogs. What else does Anne save? Anne saves code. Well, where's coding? Code is right here. So let's talk about what we did. Given an instance of Anne, we can say, hey, I have all the saves. The save is the class that stores the relationship information, not the pins. There's nothing about relationships on the pin, and there's nothing about relationships on the user. But show me all the saves. And I only want to select the saves that include Anne. Once I have those saves, now I want to actually collect those pins. What's up that way?
What are the names of the pins again?
The name, so this is the dog pin and the cat pin and the code pin. So we have,
That's what you call the variable?
yeah, that's what I call them, yeah. So you can think of it as like this pin instance is saved in a dog variable and this pin instance is saved in a code variable. Let's just like do that exercise one more time, just to like ingrain it into our minds. This is a terrible eraser, by the way. Let's say I have my user Paul. As a human being, let's have another raise of a hand. Which of these pins has Paul saved and why? Raise of a hand. Someone other than Junior. T.
We saved dogs, code, cats.
Cats and code. So how we knew that is we said, hey, I have Paul. In theory, like this data is saved in a variable called Paul, right? So what we say is, okay, I have to go into my saves and look at all of them. And I want to find the ones, or really, I want to select the ones where, hey, Paul has saved something. Hey, Paul has saved something else. Paul saved these two things. So I know that the save is between Paul and code and Paul and cats. Well, that's great, but I still don't have the pin data. Like, I know this data is saved in a variable called code, but I don't know the title, I don't know the description. But what I can do is I can, given a code, in theory, let's say this is saved in a variable called code, and then all of this is saved in a variable called cats. Cats. What I can do is say I have two instances of save that I know both belong to Paul. I can say, let's collect the pin from code, and let's collect the pin from cat. So when we have two models in a join table, we have to go through the join table to find those end relationships. Let's take a look at what that looks like in code world. So I have right here, I'm going to put in a binding.pry because I know the thing I want to build out is something like and.pins. And.pins should return a list of pins that Ann has liked. I've invoked this method and.pins, which means I hit this binding.pry. So let's think about, I have Ann. I want to know all of her pins. I can't do pin.all to get relationship information, but I can do save.all. So remember, I can do find these saves first. So right here, I can do save.all. And that is really cool. Save.all, there's exactly 4 saves. But I'm not interested in all of them. I'm only interested in finding the saves that belong to Ann first. Remember, that's exactly what we did. So how do we know what pins Ann has saved? Well, look at all the saves, but only look at the ones that belong to Ann, where user is Ann. So, save.all. How do I select only the saves that belong to Ann?
That's select.
Save.all.select. But now I have to write some more stuff. So what goes in between the pipes?
Okay.
Not quite. What so save.all.select. What is the thing we're iterating over? A save instance. So here's the way to think about it. Save.all is an array of save instances. So when I create this save.all.select, I'm going to have to put something in these pipes. The thing that I'm iterating over is really a save instance. And now I have to put in, so this is how .select works. You have to put in a condition, like a Boolean, that says whether or not you want to select this save or not. So, what condition might we have to put in? Save instance dot user equals self. What I got back was an array of saves. And who are all the users? Just Ann. That is exactly what we did mentally. So coding is really just an art of translating mental work into computer work. Like that's really all programs are. It's computers that are so dumb, we tell it to do things we don't want to do. So what did we have to do mentally? We looked at all the saves and we said, hey, only select the saves where the user is Ann, or in our case, the self, the instance we're working off of. So when we do, remember up here, when we did Ann.pins, self is Ann. I'll show you guys that again. So self is Ann. So we say, hey, here are all the saves. And I only want to, you can do select, you can also do find all. I only want to select the saves where the user is Ann. So select from this array only the save instances where the save instant.user is self. That is going to be all I need to write in order to find all the saves that belong to Anne. So I will say this. I'm actually gonna write this as a do N because I think that's a little bit more what you guys are familiar with. But just note that the one line of code I wrote is the same thing as these 3 lines. Same thing. Now what I'm going to do is I'm going to save this in a variable called users saved pins. I know that's a lot. Actually, I'm just going to call it users saves. So I'm going to kill this, run it again. And this is what I'm going to do. I'm going to do something new. I'm going to say paul.pins. Paul.pins is going to take me to, I meant to take this binding.pry and like put it down here now. Let's kill this. So let's say paul.pins. I've hit my binding.pry, but that means I've executed the code on lines 19, 20, and 21. I want you guys to just take half a minute to predict what user saves is. It is, users save. It is all the instances of save that belong to Paul. And this is great, but remember that's not what this method originally wanted. This method wanted, given a user, given Paul, I can get all of his pins. This is not all of Paul's pins. This is all of his saves. But, given his saves, so here's Paul's first save, here's Paul's second save, I know that what I really want is cats, the pin, and coding, the pin. I have these 2 saves. I want these 2 pins. If only there were a way where, given a save, I could just, collect this pin, this cat, I can just collect it here. So, users saves is an array of Paul's saves. How might I be able to get the pins from it? .map. Now, this is where it gets tricky. How .map works is just like other enumerables. You need to give it something in the pipe and something in the block. So users saves is an array of what? Saves. So we have an array of save instance. And given the save instance, how a .map works is we don't need to put in a condition. We just need to put in the thing we want to transform it to. So in this case, save instance dot pin. What I get back is an array of 2 pin instances. So this is what the pseudocode looks like. In order to get all the pins of a user, you have to first get all their saves. You go through the join table, and then you get all their pins. So, in order to find all the pins, I must first find the saves that belong to Anne first, and then I have to collect just the pins from all of Anne's saves. What's up, Brett?
Would it be a good idea to transfer out that user saves to a method so that inside of pins you just call
You could.
user saves dot whatever dot map?
You very well could do that, yes. I'm probably not going to show it, but that's a great concept. Let's go ahead. I'm going to take all this code and paste it here.
Can't we just make that first one an if statement to return the save instances, the pins?
How would we make it an if statement?
So like if you put an if before that, save instance dot user equals self.
Mm-hmm.
I don't know if we can use return or if we have to use puts.
So the concept of if, I'm going to close this door real quick. So if we're gonna have to do it for every single save. So that's essentially what .select is doing. We're saying, go through every single save. If the first save belongs to and, we want to keep it. Else, we don't want to keep it. Let's talk about the second save. The second save, if it belongs to and, we keep it. Otherwise, we don't. So select, in a sense, is using if as if this were the block. So instead of doing something like, if save instance dot user equals self. Like, we could do this, but we have to do this logic for every single save.
Well, I mean, like doing that within the select statement.
So so how a select statement works is you don't need the if. So if we say this, like, this is syntactically incorrect. But like, it's the same concept. Like, how a select block works is in between the do and the end, you have to write a condition. So you have an array of save.all. So .select, you call it off of an array. Save.all is an array. We call .select off of it. This array, for every single element in it, we're going to run this check. If the save instance .user is equal to self, we want to keep it. And we run this 4 times total. What other questions do you guys have? What's up, T?
So at first that found save that belongs to and then you type in user saves for all.
Right, so that's where we want to be flexible. We want to find the saves that belong to self, really. So depending on how this method is called, so this method is called pins. If, let's kill this pry. If I say and.pins, well, let me put in a binding.pry right here. Binding.pry. If I say and.pins, inside this pin method, and is saved in this variable called self. So what we're doing is we're saying, hey, if and calls this method pins, we're going to loop through all the saves and find the same instances where the user is and. But we want to be flexible. If we say, let's exit. If we do Paul.pins, well, what is self now? Self is Paul. In this case, we still want to go through every single save that exists. We want to go through all the saves. But now we're going to check, hey, does that save instance have a user of Paul? Because now Paul is the value of self. So in our notes, we said and because we wanted a concrete example to work with. But the reality is this method needs to work with any user. Okay, so this is our pseudocode. In order to find all the pins that belong to a user, we must first find the save that belongs to that user. And we save that in a variable called user saves. And then what we want to do is we want to take all of the saves that belong to our user and collect just the pins. Collect just the pins. And then this is going to be a do. This is an end. And then, so let's go ahead and copy. Let's save this in an array called like users pins. Let's throw in a binding.pry right here. Binding.pry. Whoops, I cannot spell for the life of me. Binding.pry. Okay, so and.pins. I've hit my binding.pry, and I have 2 variables that I've created in this method that I could take a peek at, I could pry into. So take a moment to predict what is user saves. It's all the instances of save that belong to and. So and has saved something twice. These are the 2 instances. But now, what is user pins? User pins take a second to just predict to yourself. I cannot spell it. Users, where is it? Users pins. Let me try that. Users pins is we took our array of 2 saves and we mapped over them and said, in these 2 saves, just give me the save instance.pin. Give me the save.pin, which is going to give me, hey, here's the first pin, here's the second pin. So these are the 2 pins that Anne has saved. Good dogs and coding tips. And then finally, what we can just return is user pins. Let's try this out. Paul.pins is cute cats and coding tips. What's up, Noah? So only for Paul.pins and .pins is going to return me good dogs and coding tips.
I meant if you take out return users, still return the same thing.
Good point. So if we don't have this, will it return the same thing? And .pins? Yes. Yes, it does. Ruby's nice. It has implicit return. It says, hey, since this is the last thing you did, and because .map returns user pins, we don't even have to create a variable for it. We can just say user saves.map. Let's test that this still works. What is and.pins? Yep, still works like a charm. If you guys want to see more kind of mind-blowing syntactic shortcuts, well, remember that user saves is equal to all this stuff. So user saves is a variable we created that is equal to the new array that is returned by .select. So save.all.select is going to return a new array that we store in this user saves variable. And then we say user saves.map, do all this stuff. Well, if we wanted to, I could actually take this array and immediately .map it. And .pins, same thing. It's messy, and I don't know if I would recommend that you do this syntax, but it does work. Another way you can do it, instead of a do end, you can make it an open curly. And this end is a close curly. And this is an open curly. And this end is a closed curly. Now I actually think this is kind of okay to read. What is user, in this case, now this is user pins. So what are we doing? We're saying user pins is equal to go through all the saves and select only the saves that belong to self or belong to Anne. And then immediately map through that array, and instead of the save instance, just give me the save instance.pin. This is more or less everything we did, but basically all smushed together. And then you don't even need this variable. You can just automatically have it return all of this stuff. Alex, you had a question?
That was my question.
Oh, okay, yeah. Perfect, yeah. If this is confusing, don't worry about it. I'm going to copy this. I'm going to go back. This is the more explicit version anyways. So this is the explicit version. I'm just going to put down here the short version commented out so that you guys can have this in your notes. All right, what questions do y'all have? That was a lot. Again, you can ignore the stuff that's commented out, but remember, if you have a user and you want to get their pins, you're going to have to first go through the join table, and then you can get to pins. So what do? We first get all the saves, and then we get all the pins, and then we return the pins. Okay, let's build out the opposite relationship. Given a pin, code pin, here's a code pin, I want to be able to find its users. So code pin is an instance of pin. It doesn't have a method users, but we can build one. And we are going to do the opposite relationship. Given a pin, so here's coding pin. How do I know which users have saved this pin? Can I get a raise of a hand? We'll go junior again, since you're
I did it from the saves.
You go to the saves, okay, sure, so we go here. How do we say which users have saved coding tips?
The relationship between the pin and the saves.
The relationship between the pin and save, okay, so here's the pin, and then we can, I'll do this wrong. We'll say, hey, if we have a pin about code, let's go to the saves. Here's someone who has saved code. Here's someone else who has saved code.
And then we go to the user.
And then we go to users and we say, okay, now I want to say collect the Paul user from this save, and then from this save, collect the and user. So it is really just the reverse logic. Okay, erase. So given a pin, let's say this, given a pin, or remember that, given self, I want to find all the saves that belong to this pin. Well, how do I do that? Save.all.select.
I can't just copy the all saves and just hit reverse.
Nah, I just like to type it out. I practice what I preach. Get that muscle memory. Okay, save.all, remember, is an array of all your saves. So really what goes in here is a save. And what we want is we want to select. So we want to write a Boolean condition. Only keep the save where save.pin is equal to self. Remember that given a pin, find all of its saves. So we want to say, hey, find all the saves where the pin is, coding tips. And then what we want to do is we want to collect all the users that belong, collect all the users from those saves. So save.all.select is going to give us an array of saves that only belong to the coding pin. We then say dot map. We're still iterating over a save, and now we want the saves users. So after all is said and done, I kill my pry. Here's my coding pin. I want to find all of its users. Whoops, users. Anne and Paul. Let's try a different pin. Let's try the cat's pin. Dot users, an array of just Paul. What about that dog's pin? Dog's pin dot users, an array of just Anne. What questions do y'all have? So from a user, we can find all their pins. From a pin, we can find all the users who have saved this pin. And with that, we've built out our meaningful relationships. Let's do one more. A user should have the ability to save a pin. So this is true. A user should be able to save a pin, and that pin should be added to the user's list of pins. This method should take in a pin instance as an argument. So let's create an instance method for our user class called savePin. Let's go to, and it needs to take in an instance of pin. So here's what I can do, binding.pry. So right now, if I look at and.pins, I like dogs, I like Cody. Let's say I have a change of heart and decide I like cats now. And.save pin, and I need to pass in an instance of pin. Well, I have that. I have it right here. I have my cat pin. So just reminding you guys, our cat pin, cat's pin, is an instance of pin, and is an instance of user, and.save pin, let's pass in the cat's pin, and I hit my binding.pry. What is self in this case? It's and. What do you guys think pin is? It's our cats. So now I want some way to, given a pin, save it to this user. Well, how do I create a new save? Save.new, and what do I pass in to a save.new? A user and a pin. So what I want to pass in is going to be self is the user and pin is the cat pin. So if I say, hey, and.save cat pins, well, I'm going to say self is and, pin is the cat pin, so I'm just going to create a brand new instance of save. Let's test this out. And is an instance, age 30, username and.pin. So remember that every time I close my pry, I load up all of this. So we only have 4 saves. I have not saved the cats yet. I've only saved dogs and coding. And.pins is just dogs and coding. And.save pin, let's pass in the cat pin. Cats pin. And what I get back is a new instance of save where the pin is so fluffy, so fluffy, cute cats. And the user is and. So why this is the case is because remember Ruby will automatically return the last line in that method. If I do and.pins now, and has saved 3 pins. Good dogs, coding tips, cute cats. Let's say Paul saves pin dogs pin. No errors. What is Paul.pins now? Paul likes 3 different pins. So I've built out the ability for a user to save a new pin. What other questions do you guys have? What's up, Michael?
I'm confused of how you're able to assign the self and then there was, I think, the pins thing with the user's name.
So let's look at it side by side. I'm going to do user over here and console over here. So when I do and.save pin, cat's pin, let's look at on the right, on the left, and then let's look at on the right. So on the left, when I say and.save pins, this is me invoking a method. So what happens is I'm going to go to that method, right? Now, if I call and.save pins, self is always going to, at least in an instance method, self is going to refer to the instance that called this method in the first place. So that is how self is equal to and, because we called this method from and.save pins. And then what is pin? Pin is just the thing we passed in, which is our cat's pin. Cool. How are we doing on time? Let's do a couple of stretch features that I'm not going to go into detail with. These are more just sit back, relax. You can come back to them later. User, number of saved pins. Given a user, how can you figure out their number of saved pins? Well, this is an instance method for user. Let's go to user and create a new instance method called number of saved pins. Well, remember that self is always going to refer to your user. Self dot pins is going to give you all of their pins. Dot count is going to tell you how many pins they have liked. If I say Ann dot pins, Ann has liked 3 pins. Perfect. Ann dot number of saved pins is 3. What is Paul dot pins? Paul only likes 2 pins. So what is Paul dot pins dot Paul dot number of saved pins? Just 2. Last stretch feature. Given a pin, find the average user's age. This is interesting. I hear some people starting to brainstorm this. Now remember, inside the pin class, self is always going to refer to an instance of pin. Just like in the user class, self is always going to refer to an instance of user. So here, self is, here's all the pins. And then you can say dot users to get all the users. Let's just see where we're at here. So given coding pin dot average user age. What we have so far is we return self.users. This is all the users that have liked coding pin. Now what I can do is I can say dot each. And there's many ways to solve this. There's more eloquent ways, but I could say, you know what? How do I find the average? Well, the average is just the total sum of the ages divided by the number of users. So this is what I'm going to do. I'm going to do some sort of each because I know I'm going to have to go through each of the pin's users. And yeah, there might be a more eloquent way to do this, but I'm just going to say the total sum. I'm going to have this start off as 0, and I'm going to have the number of users also start off at 0. And this is what I'm going to do. For each user, I'm going to say total sum plus equals user.age. So this is, actually I'm going to call this total age. So this is, I'm going to go through all my users and add all their ages together. And then what I'm going to do is I'm going to keep track of how many users I've passed. So I started at 0 users, and then I'm going to say, okay, each time I iterate through, I'm going to add 1 to this running count. The final thing I can do is I can return total age divided by number of users. So given a pin, what is the average age of the user? 35. That makes sense. I'm 30-ish. Paul's 40-ish. What if I do dog pins dot average user's age? 30. Because only one person likes dogs. 30-year-old Ann likes dogs. Cats pins dot users. So cat is liked by both me and Paul. Remember that I had a change of heart. So what is cat pin dot average user age? 35. All we're really doing is combining everything you learned about Ruby in your pre-work. You guys learned how to increment. You guys learned how to do .each. And we're applying it to an object-oriented perspective. What questions do you guys have? What's up, Lisa?
While we're in P, when you say self.users, can I see what users is?
Of course. So self is, right now, so this is an easier way. So when we say self.users, remember self is a pin. So if self is a pin, what happens when we say, pin, like pin 1.users? Well, that's going to take us to this method. So what we've done is we've used the user's instance method as if it were a helper method to get more information. So you guys have done that before. In your pre-work, maybe you created a helper method that's going to be used elsewhere. That's what we're doing here. We're saying, hey, if I want to get the average user's age, I'm going to have to first get all the users. Well, good news for me, I already have a method to do that. I just have to call it. Well, how do you call an instance method off of an instance? Self is an instance of pin. So self.users is just saying, hey, call the user's instance method. Okay, I'm going to go ahead and stop the recording.